All right. I I kind of solved the problem of this circuit at least. All right. All right. So this is me filming my monitor, my wide monitor. So this is the circuit that I'm using there on the breadboard. It's using a 7400, which is an AND gate with 470 ohms resistors. Probably I used 1 kilo, and that's it. The output goes to a frequency counter, and here I'm testing the crystal oscillator between the input of the first and output of the second. Like I said, I have two tests that I'm doing in the same time right now. Originally, I wanted to make the movie only for this, but since I have this already here, I will talk first about this and then about this guy. So I tested. The idea was simple, very simple idea I had, and it worked, and it confirmed to me that all these motherfuckers crystals are bad, are absolutely bad. 32 kilo hertz. What I did, the test that I did was to use. I wasn't sure about the circuit itself either, so I used an older circuit. I did test this circuit, exactly this circuit. I did test it a long time ago, and I had to dig out my older circuits and look in a notebook that I am keeping with a lot of circuit diagrams and search for it. And finally, I find it, and I build it here very quickly, as you can see, 7400. And what I did here, the idea was simple. First, to test the circuit that I'm using here, and second, to test the crystal, those motherfuckers. Actually, I have it here prepared. And the idea was to use this counter, and if the circuit is good, and also the crystal in the same time must be good, this counter will go to 888. As you can see right now, it is on maximum frequency, is spinning extremely fast. That's what it's doing right now, because the frequency is very fast. So it's a very simple idea what I did to test if the crystal and the circuit is working. And if I'm taking out the crystal, it's just stopping at a random number from that very fast counting. And now when I'm setting this guy, the 32 ones, let me find exactly the points, is doing absolutely nothing. It did increment because I moved something here. But if I'm resetting here, it's staying on 0, and it's doing nothing. Theoretically, this should also increment very fast. I'm not sure why it's moving that. Probably I'm moving something here. It's touching. Theoretically, it should behave as with the 9 megahertz. It should count very fast, and I should be able to see 888 here, exactly like that. Maybe a slower speed, probably a little bit more flickering than with that 9 megahertz there. But the idea was to see very fast movement, to see that 888 counting, the full maximum speed that this counter is able to display pretty much. So now let me change this. Definitely I moved some wires there, especially these resistors that are having very thin, you see, if I'm touching them, very thin wiring, and they're making dubious contacts there. And now if I'm inserting this, it's changed to 888, which means a extremely fast speed. So this little experiment that I did here is confirming that the circuit is good, and also this crystal oscillator is bad. And also this crystal oscillator I know is good because I tested it here, and it doesn't matter what I'm using. In this case I use this 9 one that I know for sure here is working absolutely without problems. This device is reading it instantaneously. The first touch I'm making is reading it, that quartz oscillator. But this motherfucker, this guy didn't read it at all. On any other circuits that I make abstraction of this, because this is part of the experimentation I did. I used an op-amp there and one transistor, and it didn't work at all with this version that I tried. I also used that that op-amp. I use it with 7404, which is a NOT gate here, and very similar circuit with this one, but with a NOT gate instead of an AND gate. And with this guy, it didn't work at all. But I don't remember if I used this 9 megahertz there. This is the first circuit to be sure, because I look back in what I did in the past. So I duplicate what it worked in the past pretty much. What you're seeing here in this little thing. With a minor detail, this little capacitor that you see here, in the newer versions, I have it plugged in there to the minus, from one leg of the crystal to the ground, pretty much. This is the capacitor, but it's working fine without it as well. If I'm taking it out, you see, it's stopping randomly somewhere, and if I'm resetting it, it's starting to move very fast. And so it is working without that capacitor as well. Probably that is more for stability, for something that, but for this kind of test that I'm having here, I don't. It's either way, it's fine without it. Now, this is it. I know for sure now that these motherfuckers, all of them, are bad. I know for sure now. Absolutely for sure. Now, another problem that I also raised, and others, I was discussing this problem on a forum, and others hooked up to this idea that maybe it needs a special circuit, this guy, or a special setup to make it run different or more special than the megahertz. And they pointed out, the guys on the forum, they pointed out that I'm using the megahertz, all the crystals that I tested in my last video, my preview video that I made all the tests with megahertz range, but not kilohertz, which is very low comparative with those megahertz that I'm having there. And it was a good point. And also they told me that this kind of circuit is not able to count as low as 32, that is made for megahertz counting, is their argument. But my argument is that it doesn't matter. As long as it can count very fast, it can count very low as well. Down to 1 hertz. It should be working with this kind of circuit, with any counting, with any driver. This is a driver for crystals. So any kind of driver for crystals should be able to count down, well, to read lower frequency up to its maximum. I don't know which is its maximum, probably 100 megahertz or something. I have to look in its datasheet. It's dependent on the integrated circuit that I'm using here. Its maximum range probably. But under that maximum range of the chip, it should read any kind. Doesn't matter what I'm inserting there, even if it's not crystal, even if it's something else that is different from a crystal. This is my argument. This is my opinion, of course. I cannot say that this is good or bad for that guy specifically, but it is good only for the megahertz one. I cannot say at this point if this is good from this experiment, how good it is for these guys. Maybe this guys really needs a special driver. I already made a purchase of a new batch of 20 pieces of crystal oscillators, but this time I bought a little bit more higher price. These guys, I paid them for them around $2, one and a half something, probably less than $2, but very close to $2 on all the batch, all the 20 pieces. And this time this time around I buy a little bit more expensive crystals at $3, but they are SMDs 1206 or 3015 in metric, 3 millimeter with 1.5 millimeter size of the, so they are quite small SMD versions, and I will solder some legs and I will test them. Also 32 kilohertz crystal, exactly the same frequency with these guys. And after 1 month from now, when they will arrive, and I want to believe they will be good and not to repeat the history too. So I didn't buy these guys anymore. This model with the metallic tube like that, I didn't buy them at all because I was afraid history not to repeat itself and to get another batch of also fucked up motherfuckers. And I buy different package, pretty much different package like the SMD ones, and hopefully those SMDs will be more serious. All right, so now let's get to the second project that I'm having here. What I did, this is a this says there variable. It says variable frequency generator. It's made with a 555 integrated circuit. Here I have a scale that I made it. It's a logarithmic scale. It's not a linear at all. It is literally jumping almost, you know, from, especially here in the end, it's just from what is there? From 100 hertz. You see that the black line is just jumping, and the maximum is 1.2 kilohertz actually. But yeah, so it's 1000 bits per second, 1 kilohertz. So now let's see here. It's on 2. And it is displaying 2. Usually it's near it, near that value. And now I'm switching to 30 here on the dial. It's 30, and this is showing me 32. If it's staying too much on the same frequency, it appears that it is blipping on and off, which is very, very annoying. Very annoying design. Yeah, it's kind of 100. So here is 96, and this here is the maximum at 1 kilohertz, and this is showing me 1.2 kilohertz. Yeah, 1215 hertz. This is what is showing here, 1000 hertz. And if it's lower like this, here is 13 hertz, and here is very, very low, 2 hertz, 1 hertz, no, 4 hertz, 5 hertz, 50 hertz, 28, depends. Yeah, okay, 50 is a bit more here. So it's higher a little bit, and as long as I'm increasing it, you see, it's showing the hertz value. How many hertz? 1000 hertz, 1200 hertz. And the idea is that this is showing the very low frequency up to 1 hertz. And yeah, this is my second test. So this device, what I'm having here, should have shown me the value of all of this 32 kilohertz easily. So this was another issue that I had. The argument was maybe this device is not reading lower than megahertz. The only crystals that I tested last time, this guy here's, they were in range of megahertz, and some guy told me, yeah, but you only tested megahertz, but this being kilohertz is too much difference, and this device might not read it correctly because it is lower, very low frequency. But as you can see, I got even lower than 32 kilohertz. I got 1 hertz, 1 single bit per second, and a couple of hertz, and it did a good job reading. So between these two maxims, very low and very high, this should have been read quite easily, and it wasn't. So this is it for this part. Now the conclusion is that now I know for certain, I am very certain, that these crystal oscillators that I'm having here are absolutely busted, absolutely garbage, and I asked my money back already. It's not much, like I said, it's less than $2, $1 and something, but why should I pay on garbage? I don't want this. These guys I will throw them away. I cannot do anything with them, pretty much. And what I'm very pissed off is the time that I had to wait for them. 1 month to arrive. And it took actually more than 1 month. It took like 1 month and a week, 1 week or something, or 10 days. And that's what I'm very, very pissed off. And it also elongated the project. I have to wait for those fuckers to actually build what I want to build. I'm very, very disappointed. Yeah. For some reason, this is fluctuating here quite. Yeah, I have bad wires probably. That's why it's fluctuating there. This should be 1000. Come on, bad wires. motherfuckers. Yeah, no, you see, this motherfucker wire is a bit trouble, but either way, it's fine. So yeah, this is it. All right. Thank you very much for watching. I hope you like my tests that I did and the logic that I put into it, and I hope it will help someone else with similar problems. If you don't know what value of the crystals you have or components, do some tests and don't believe only one source of reading. Like my device, I didn't trust only one device, only this guy here. I didn't trust it. I had to build a secondary circuit, actually multiple circuits, until until it gave me a certain response. I mean, now I'm absolutely sure what they are. They are busted. They are bad, and I do trust. Come on, like that. Huh. Yeah, probably the wire is fucked up inside. So I'm very sure these are busted and they are bad, and that's it. All right, thank you very much for watching. I hope you like it. See you next time when I'll do something else. Bye bye.